Bismillahirrahmanirrahim. So far, we have discussed about the different renewable energy technologies. Now, we are going to discuss one of the most important clean energy technology, which is the fuel cell. We have discussed about the solar energy, we have discussed about the wind energy, and we have learned about the hydro energy. All these energy that we have discussed were renewable energy technologies that they were producing themselves, but fuel cell is not a renewable energy technology. It cannot run continuously without reproducing itself. It is clean energy technology because it produces no carbon emissions. That's why we call fuel cell as the clean energy technology, not the renewable energy technology. What is a fuel cell? A fuel cell is simply an electrochemical cell that converts the chemical energy of a fuel directly into an electrical energy. Fuel cell, from its definition, is an electrochemical cell. And in this electrochemical cell, we convert the chemical energy of a fuel. Normally, the fuel of the electrochemical cell is hydrogen. So we basically convert the chemical energy of hydrogen into an electrical energy directly. There is no combination of hydrogen and oxygen, and there is no burning in it. We just causes the hydrogen to react with oxygen electrochemically, and then we produce electrical energy from the fuel cell. Fuel cell provides an efficient and clean mechanism for energy conversion. It is the clean as its byproduct is only water, and water has no effect on our environment. That's why fuel cell are considered to be the clean and energy efficient mechanism. They are also regarded as the energy conversion devices of the future. Future economy is known as hydrogen based economy. So in a fuel cell we convert hydrogen into electricity, and our future is based on hydrogen economy. That's why fuel cell are said to be energy conversion device for the future. Due to its static nature, fuel cell also mean quiet operation without noise or vibration, while their inherent modularity allows for simple construction and a diverse range of application in portable, stationary and transport power generation. It has no vibration, no dynamic part. That's why it is static, and it has a diverse range in portable, stationary and transport power generation. Now we are going to look at the working of the fuel cell. As we have discussed that fuel cell is an electrochemical cell, and in electrochemical cell we have two electrodes. One electrode is known as anode and second electrode is known as cathode. We know that anode is positive and oxidation occurs at anode, while cathode is negative and reduction occurs at cathode. Between anode and cathode we have an electrolyte, and anode and cathode are connected via an external circuit. At anode we supply hydrogen which gets oxidized, and at cathode we supply oxygen which gets reduced. At anode oxidation occurs, means loss of electrons occur. Hydrogen is break into proton and electron. As you can see from this equation, that hydrogen is break into proton and electron. Electrons are transferred via an external circuit, causing the current to flow, because we know that the flow of electron is known as current. So due to flow of electron through the external circuit, we have electric current, and the proton, which is the nucleus of the hydrogen, and we know that hydrogen nucleus only contains proton. Proton will travel through the electrolyte, which is the proton exchange membrane electrolyte. At cathode, oxygen, electron and proton combine to produce water, which is the byproduct of the fuel cell. I am repeating the working of the fuel cell. That hydrogen comes at anode. At anode, oxidation of hydrogen occurs. Hydrogen is break down into electrons and protons. Proton is basically the hydrogen nucleus. In hydrogen nucleus, we know that there is only one proton, so we can say hydrogen nucleus to be proton. Hydrogen proton travel through the electrolyte, and the electrons travel through the external circuit, causes the current to flow. We know that the flow of electron is known as current. At cathode, hydrogen, proton, electron and oxygen gets combined to form water, which is eliminated from the fuel cell continuously. So this is how a typical fuel cell works. This is the hydrogen based fuel cell, and this is how it works. At anode, hydrogen oxidizes into hydrogen nucleus, which is known as proton and electron, and at cathode, oxygen get reduced to form water by accepting the electron from the external circuit and proton through the electrolyte. Now, as I have discussed that there are three basic elements of fuel cell, which are electrode, fuel electrode, and it is known as anode. One is oxidant electrode, which is known as cathode, and there is an electrolyte. Electrodes are made up of porous material and are covered with the layer of catalyst. The electrodes of the fuel cell are made up of porous material, and they are also covered with some catalyst. The catalyst causes the oxidation and reduction reaction to occur. Molecular hydrogen is supplied at anode, where it goes through electrochemical oxidation and produced hydrogen ions and electron. As we have seen from last slide, that we have supplied the molecular hydrogen at anode, where it goes through electrochemical oxidation. Oxidation is occurring, it means that there is a loss of electron. Hydrogen gets oxidized, forming hydrogen ions and electrons. Electrons travel through the external circuit, and this was the reaction occurring at anode. We have supplied hydrogen at anode. Hydrogen is converted into hydrogen ion, which is also known as proton, and are converted into electrons. Electron passes through the external circuit, and protons or hydrogen ions travel through the electrolyte. We have supplied oxygen at cathode. Hydrogen ions and electrons combine with oxygen at cathode to form water. As we have seen in previous slide, that oxygen gets reacted with hydrogen ions and electron through the external circuit and forming the water. So this is the reduction reaction occurring at cathode. The first reaction is the oxidation reaction, which is occurring at anode, while the second reaction is the reduction reaction, which is occurring at cathode. If we talk about the overall fuel cell reaction, then in fuel cell, water is formed by the electrochemical reaction between hydrogen and oxygen. Hydrogen and oxygen gets electrochemically reacted to form water, and we also get electricity and we get heat because the reaction of water and hydrogen, formation of water is basically an exothermic reaction. That's why we get some heat from the fuel cell, and we are getting electricity to be formed, or we are gaining the current in external circuit. That's why we get electrical power. So if we talk about the overall reaction in a fuel cell in a fuel cell, hydrogen and oxygen gets reacted electrochemically to produce water, and we get heat and electricity from a fuel cell. So from this working, I hope that you notice one thing, that there is no dynamic equipment in a fuel cell, causing it to be the static equipment. And there is no dynamic equipment, it means that low maintenance is required for fuel cell. We know that for dynamic equipment like heat engines, we require a lot of maintenance, a lot of lubrication, and there are too much losses in dynamic equipment. But in fuel cell, there is no dynamic equipment, causing it to be this static in nature. That's why fuel cell is static in nature and is efficient device. Now we are going to compare fuel cell with heat engine. In heat engine, we know that we have a chemical energy of a fuel, and normally we use natural gas, any furnace, any fossil fuel for chemical energy. So basically fossil fuel provide us chemical energy. That chemical energy is converted into heat. If we talk about steam power plant, then we use boiler to convert chemical energy of a fuel into heat. Then heat is converted into the mechanical energy through the turbines. We have heat content. That heat content is converted into the mechanical energy through the turbines, and then turbines are coupled with generator to produce electrical energy. So this is how a typical heat engine works. First, the chemical energy is converted into an heat, then heat is converted into the mechanical energy to the turbines, and then turbine is coupled with the generator to produce electrical energy. So this is how a typical heat engine works. As you can see that there are three conversion processes. First, chemical energy is converted into heat, which is another form of energy. It means that chemical energy is converted into heat. There is an energy conversion in a boiler, and we know that when one form of energy is converted into the another form of energy, it causes some losses. So when chemical energy is converted into heat, there will be some losses. Not all of chemical energy will be converted into heat. When heat is converted into mechanical energy, we know that when heat is converted into mechanical energy, there are some other losses. So that's why heat will not convert it into mechanical energy. And when mechanical energy is converted into an electrical energy through the generator, there will also some losses, because mechanical energy will not convert it entirely on the electrical energy. So in all three conversion steps, we have some losses associated, which causes the ultimate or the entire efficiency of the system to be dropped. But if we talk about fuel cell, in a fuel cell we have chemical energy, we have hydrogen which has chemical energy, and the chemical energy of hydrogen is converted into an electrical energy. There's only one step. There's only one conversion step. So that's why the overall system efficiency of a fuel cell is higher than the heat engine. In heat engine, first we convert chemical energy into heat, then heat converted into mechanical energy, and then mechanical energy is converted into an electrical energy, causing the three conversion steps. More conversion steps causes the decrease in system efficiency. While in fuel cell we have chemical energy of hydrogen which is converted into an electrical energy. So there is only one conversion step, so there will be higher efficiency or low losses. And we know that more energy conversion lowers the system efficiency. I hope that this comparison is clear up to you. If we further talk about the comparison, both fuel cell and heat engine use hydrogen based fuel and air for oxygen supply. One thing which is common in both fuel cell and heat engine is that they both uses hydrogen based fuel. We normally use methane, petrol for heat engines, and we know that methane and petrol or any hydrocarbon are basically hydrogen based fuel. So there is one thing in common between heat engine and fuel cell is that both fuel cell and heat engines uses hydrogen based fuel and air for oxygen supply. In fuel cell, the fuel and oxidant combine electrochemically, while heat engine combines the fuel and oxidant via combustion. There is a combustion occurs in heat engine. We know that there is a combustion in heat engine which causes the fuel and oxygen to combine, while in fuel cell there is no combustion but fuel, which is hydrogen, and oxygen combines electrochemically. Fuel cell produces electrical work directly from chemical energy, while in heat engine producing electricity is a multi-step process. As we have seen from previous slide, that in fuel cell electrical work is directly converted from a chemical energy. We directly convert chemical energy directly into an electrical energy in a fuel cell, while in heat engine, if we want to produce electricity, then there will be a multi-step process, as we have seen in last slide. Generally, as the number of energy conversion processes increases in a certain device, the overall system efficiency of this device decreases. As we have discussed in previous slide, that as we increase the number of energy conversion processes, then it will cause the overall system efficiency to be dropped. Fuel cell, in comparison to heat engines, produces fewer to zero pollutant and have higher theoretical and practical efficiency. There is only one byproduct of fuel cell, which is water, and we know that water has no negative impact on fuel cell. There's only one byproduct from fuel cell, and we know that water, which is a byproduct of fuel cell, has no impact on environment. So fuel cell produces no emission or very low pollutants, while heat engine produces a lot of carbon emissions, which is very dangerous to our atmosphere. And also fuel cell have higher theoretical and practical efficiency. We will discuss in future lectures that how efficiency of fuel cell is higher than the heat engines. Heat engines are limited by Carnot efficiency between their low and high working temperature and are responsible for a significant portion of world's pollution. As we have discussed that heat engines are limited by Carnot efficiency and they are also responsible for significant portion of world's pollution, while the byproduct of fuel cell is only water, and they are no responsible for world's pollution, and their efficiency is not limited by Carnot efficiency. We will discuss about the efficiency of fuel cell. Fuel cell stacks are static device that operate with almost no noise or vibration. As we have seen from the animation of fuel cell, that fuel cell is entirely an static device. Due to its static in nature, they produces no noise and vibration. As we have seen, a lot of noise and vibration from a heat engine, while in fuel cell there is no noise and vibration. I hope that this comparison of fuel cell with heat engine is clear up to you. Now we are going to compare fuel cell with a battery, which is also an electrochemical cell. Normally people gets confused with fuel cell and battery. They think that both are same. No, they both are different. Fuel cell is basically an energy conversion devices, while battery is an energy storage device. Fuel cell and battery both are similar in operation, and both are electrochemical cell, and they both are consist of two electrodes and filled with electrolyte. One thing which is common in fuel cell and battery is that they both are electrochemical cell, and we have discussed that electrochemical cell uses two electrodes, one anode and cathode, and an electrolyte. So in in fuel cell and battery, this thing is common, that they both are consist of two electrodes and they both are filled with electrolyte. They both use internal oxidation reduction reaction to convert the chemical energy content of a fuel to DC electricity. They both uses oxidation and reduction reaction. In electrochemical cell, we know that there are two reactions, one is oxidation and one is reduction. So in electrochemical cell, we convert basically the chemical energy into the DC electricity. But battery stores electrical energy in the form of chemical energy, and then the chemical energy is converted into the electrical energy. If you read the third point, the electrodes of a battery are made up of metal immersed in an acid. In fuel cell, the electrodes, that is catalyst layer and gas diffusion layer, typically consist of proton conducting medium, carbon supported catalyst, and electron conducting fibers. The electrodes of battery are normally made up of metal. We use metal electrodes in battery. If we talk about lead acid battery, then we use lead as a electrode in lead acid battery, and we have electrolyte in the form of acid. While in fuel cell, we have electrodes which are covered with catalyst layer. We have metallic cathodes which are covered with catalyst layer and gas diffusion layer, and the electrolyte is basically proton conducting medium, because we have, as we have learned from animation, that electrolyte conducts protons. So that's why we require proton conducting medium, carbon supported catalyst, and electron conducting fiber. This is the difference in structure of battery and a fuel cell. Battery stores as well as convert chemical energy into electrical energy, while fuel cell only converts chemical energy of a fuel into electrical energy. Battery is a energy storage devices. It will run on the conversion of chemical energy into electrical energy. We do not put some chemical energy into the battery. There is no addition of chemical component in batteries. We just charge the battery, and during charging, the applied electrical energy is stored into battery as a chemical energy, and while discharging, we converted the chemical energy into the electrical energy. So batteries run as long as charging is available, while fuel cell is not an energy storage device. It is just an energy conversion device, and we have learned that it converts chemical energy directly into the electrical energy. A battery uses the chemical energy stored in its electrode to fuel the electrochemical reaction that give us electricity at a specified potential difference. As I am saying that battery stores chemical energy, and the stored chemical energy is converted into an electricity through the electrochemical reaction. That's why a battery has a limited lifetime and can only function as long as electrodes material is not depleted. Basically, chemical energy is stored on electrodes, and battery runs as long as electrode material is available. While Fuel cell can run continuously as long as the reactants are available. If we continuously supply hydrogen and oxygen to a fuel cell, it will run continuously. As we cut the supply of hydrogen and oxygen, the operation of fuel cell will stop. So I hope that this comparison of battery and fuel cell is clear up to you, that fuel cell is an entirely an energy conversion device, while battery is an energy storage device. Battery stores electrical energy in the form of chemical energy, and then we convert chemical energy into electrical energy when we discharge battery, while fuel cell converts chemical energy of a fuel directly into an electrical energy. Fuel cell can run continuously as long as the reactants are available, while battery cannot run continuously. It will run only until the charged material is available on their electrodes. So this is the difference of fuel cell and battery. We have learned the comparison of fuel cell with heat engine, and we have learned the comparison of fuel cell with battery. And we noticed one thing: in heat engine and fuel cell, both uses hydrogen based fuel, but fuel cell is more efficient than heat engine. And in battery, we learned one thing, that fuel cell can run continuously while battery can't run continuously. Now we are going to discuss Faraday law, which is applicable to any electrochemical cell. For any electrochemical cell, we have cathode, we have anode. At cathode, reduction occurs, and at anode, oxidation occurs. And we have an electrolyte in an electrochemical cell. There are two laws of Faraday related to electrochemical cell. First one is, for a specific charge pass, the mass of the product formed are proportional to the electrochemical equivalent weight of the product. And second one is, the amount of product formed or reactant consumed is directly proportional to the charge pass. Charge pass is basically the current. So the amount of product formed in an electrochemical cell, reactant get consumed and product is formed. So the amount of product formed or reactant consumed is basically directly proportional to the amount of charge pass, or we can say that the amount of product formed or reactant consumed is directly proportional to the current, because we know that charge pass means flow of charge, and flow of charge is known as current. So for any electrochemical cell, the amount of product formed or reactant consumed is directly proportional to the amount of current. In order to understand this law, consider a purely electrochemical reaction with an understanding of discrete nature of charged particles that carry current. It seems obvious that there is proportional relationship between charge pass and consumption or production of involved species. In any electrochemical reaction, the amount of product formed is directly proportional to the current pass, and this proportionality is based on the balanced electrochemical reaction, which is given by this equation. Here Nx is the Ia over Nf. Nx is the rate of molar consumption or production of species X. For any electrochemical reaction, a species is consumed and a species produced. One species gets consumed and one species is formed. So Nx can be any species, and it is Nx dot. So it is the rate of molar consumption or production of any species. Capital I is the current, and A is the superficial area of the electrode. Small I is the current density. N is the equivalent electrons per mole of reactant. It means that how many electrons are evolved or how many electrons are involved in 1 molar reaction. And F is the Faraday constant or charge equivalent on 1 equivalent mole. So this is how we can determine how much particular species will form or consume in any electrochemical reaction by Faraday law. And Faraday determines that the amount of product formed or species consumed is directly proportional to the charge passed, and it is given by Nx is equals to Ia over Nf. Now we are discussing about the Faraday constant. Faraday constant represented by F, it is nothing but the charge per mole of equivalent electrons. Charge per mole, we know that in 1 mole there are 6.02 exponent 23 particles. If we talk about charge per mole, it means that in 1 mole charge there will be 6.023 exponent 23 electrons. And if we talk about number of electrons in 1 coulomb, then it will be 6.242 exponent 18 electrons. So Faraday constant will be the charge per mole of equivalent electrons. So it will be 96,485 coulomb per equivalent. We are going to consider the oxidation reduction reaction at the cathode of many fuel cells. In a fuel cell, the oxidation reduction reaction occurs, and at cathode reduction occurs. This was the reaction that we have learned in previous slide, that at cathode oxygen gets reduced by gaining the electron from the external circuit and forms the water. Now from this reaction equation, you can see that there are 4 moles of electron react per mole of oxygen. There is 1 mole of oxygen is reacting to produce 2 moles of water, and in 1 molar oxygen there are 4 number of electrons involved in a reaction. So in this case, the charge carried per mole of oxygen reacted would be 4F. For oxygen, the value of N will be 4 because there are 4 electrons are involved in 1 mole of oxygen. While if we talk about hydrogen, so 1 molar hydrogen is responsible for 2 electron product evolution. So for hydrogen, charge carried will be 2F. So for hydrogen, the value of N will be 2 because there are 2 electrons available for 1 mole of hydrogen reaction. The scaling factor N is defined as the number of electron transferred per mole of species of interest. If we talk about oxygen, so the number of electron transferred is 4, while if we talk about hydrogen, the number of electron transfer is 2. So with that, we have done with our lecture. I hope that this lecture is clear up to you. If you have any query, any question related to this lecture, then you can ask in live session. You can also comment on Google Classroom. This is all from my side. Thank you for watching this video.